So in this problem, we're finding the empirical formula of a compound of unknown composition. Okay, so we're told that we have a 0.00300 gram sample of naphthalene, which is a compound that contains only carbon and hydrogen. And if we combust this or burn it in excess oxygen, it gives 0.0103 grams of carbon dioxide. Right? We're going to determine the empirical formula of naphthalene and then also figure out the molecular formula of it, given that the molecular weight of it is 128 AMU, or grams per mole. So let's start with what we know. So naphthalene. What elements are in naphthalene? Carbon and hydrogen. But we don't know their substrates. We don't know how many carbons, we don't know how many hydrogens, right? So we can write that right now as just CXHY, right? We're going to be figuring out what X and Y are. Now, what else are we told about this? It's burned with excess oxygen. So we can write kind of the chemical reaction of that, right? So what's oxygen?
O2.
O2.
Gas.
And what does that produce? CO2? Does it produce anything else? And H2O. How do you know it's H2O?
No, it's combustion.
It's a combustion reaction. Whenever you burn something in oxygen gas, it goes through a combustion reaction. And naphthalene, considering it contains carbon and hydrogen, is a hydrocarbon. And when you burn a hydrocarbon in oxygen, it produces CO2 and H2O. And we're actually going to be talking a lot about reactions next unit. That is what the whole unit is on. Okay? So let's figure out, or let's write down the information we have about each of these substances. How much naphthalene did we burn? 0.00300 grams, right? How much oxygen did it burn in? Excess. More than enough, right? Plenty of oxygen. How much CO2 was produced?
0.013.
And what about the water? How much water was produced? We don't know, right? It doesn't say, and in fact, we actually don't care. It doesn't matter how much water is produced, okay? Because we have enough other information to figure out the empirical formula of naphthalene. Now, in order to calculate or to determine the empirical formula of a substance, what about the elements in that substance do you need to know? The moles, or you need to be able to calculate the moles of them, right? So we need, yeah, exactly, we need the grams of both the carbon and the hydrogen in naphthalene. Or we would need the percentages, which you then just assume that those are the grams, right? So we need to figure out the grams, oh wow, my pen is like freaking out. We need to figure out the grams of both carbon and hydrogen in naphthalene. So then convert them to moles, divide by the smallest, multiply by whole if necessary, go through that whole dance, right? So how can we figure out the grams of carbon that are in naphthalene? Look at the information given. Yeah?
So you can use the number of grams of CO2 and then find out how many moles of carbon are in that. It has to be equal to the number of moles of carbon in that.
Exactly. All of the carbon in CO2 came from what? The naphthalene. All of the carbon in CO2 had to come from naphthalene because it's not anywhere else in the reaction. Whoa, exactly. All the carbon in naphthalene got converted into CO2. Okay? So, and especially because this is our limiting reactant. It's not in excess, with more than enough oxygen. Okay, so all of that naphthalene gets converted into CO2 and H2O. All of the carbon in the naphthalene becomes the carbon in the carbon dioxide. So we can do some math, some stoichiometry. So what's going to be my first step in my stoichiometry problem? Go to moles of CO2, right? So we need the molar mass of carbon dioxide, which is 44.01. And then what?
Multiply the carbon.
Yeah. How many moles of carbon are in 1 mole of CO2? 1. And we're actually going to go one step further and go to grams because we can't stop at moles because then we can't do anything with it later. And you'll see what I mean just a little bit. So now we're going to go from mole of carbon to grams of carbon using the molar mass, which is 12.01. So go ahead and calculate the grams of carbon in naphthalene. What'd you get? 0.00281. All right, so that's how many grams of carbon are in naphthalene. I also need the grams of hydrogen. How can I figure that out? I can subtract, because I know how much naphthalene I have, and I know the amount of that was carbon, so if I subtract, I'll get the amount that was hydrogen. So I had 0.00300 grams of naphthalene. I'm going to subtract out the grams of carbon to get the grams of hydrogen. And if I recall correctly, it's 0.00019 grams of hydrogen. Do I have an extra 0? No, I'm good there? Okay. Go on. It depends on the problem. So if the problem specifically asks, what is the mass of carbon, the mass of hydrogen, then yes, you would need to worry about sig figs because it's asking for those individual steps. But technically here, we don't have to worry about it because all it asks is what's the empirical formula. So you could, now, don't use, when you don't have to worry about significant figures, because of in a problem like this, don't carry through less significant figures than what you would need to have should you care about it. You know what I mean? So even though we don't care about sig figs, I don't want to round this down to any less than the appropriate number. You can carry more than what you care about or what you would need, but don't carry less. Does that make sense? All right, so now I know the grams of both my carbon and my hydrogen. So now I can do empirical formula. This is an old hat, right? So we're going to take the mass of carbon and the mass of hydrogen and convert them both to moles. Now the reason why I said earlier, when up in red, when I was finding the grams of carbon from the CO2 grams, I said we have to go all the way to grams. We can't leave it in moles, and that's because we had the grams of naphthalene. We can't subtract moles from this. That's why we had to go to grams. So convert both of these to moles. Yeah, I'm pretty sure is it 3 zeros? 2, 3, 4? I've only done this problem a couple times now. And then this one is
3 zeros. 1.
yeah. All right, now what do I do?
You multiply both by the lowest value.
We don't multiply, we divide. So we want to get the ratio, right? So we're going to compare them to each other. Divide them both by the smallest number, which is the 0.00019. And this would be 1 hydrogen, because anything divided by itself is 1. And roughly, what is that for carbon?
1.5.
Kind of close to 1.25. It's like 1.24, right? So it's like 1.25. When you're doing empirical formula, there's a few things that you want to try to get to. Obviously, ideally, you get a whole number, right? Because then you don't have to worry about multiplying. But if you can't get a whole number, you want a 0.5, because then you can multiply by 2. A 0.25 allows you to multiply by 4. And like a 0.33 allows you to multiply by 3. Okay, so those are kind of like the 3 you want to go for. If you're getting something other than that, like if you're getting like a 0.8, like a 0.82, you might have done something wrong that got you there, okay? So if the numbers don't work out to like a whole number, like a 0.25, a 0.33, or a 0.5, then you might be wrong somewhere. You might have made a hopefully careless error that you can fix easily. Most often, it's you think of something as being diatomic when it really isn't. Like for example here, when we converted from grams of hydrogen to moles of hydrogen, if you use 2.02 instead of 1.01 as the molar mass of hydrogen, that's often where a mistake is made. It's thinking something's diatomic when it's not, because here it's in a compound, so it's not diatomic. Got it? All right, so now we can multiply. What did we say we were going to multiply by? 4. We're going to multiply both by 4. We get 4 hydrogens, and what is 1.25 times 4? 5. 5 carbons. So my empirical formula for naphthalene is what? C5H4. Now the problem asks for both the empirical and the molecular formulas. So in order to find the molecular formula, I need the molar mass of my empirical formula, which is what, like 64.09 or something like that? 08, 64.08? So that's the molar mass of that empirical formula, which I then divide that into the 128, which was given in the problem, which is roughly 2, right? It's about 2, which we then distribute through the empirical formula to get the molecular formula, which would be C10H8. I'm going to stop this. Can never find where everything goes. There we go. Stop capture.